Okay, let's look at lesson 80 in Saxon Math 54. It looks like in this lesson we are going to be dealing with division with zeros in three-digit answers. So, as before, it's always smart to review a little bit on some previous concepts and to continue to practice what you already know. In order to feel more and more confident with math, you do it every day, and you do a little bit every day, and you stay consistent, and little by little you're going to improve, and it's going to become easier and even more enjoyable. Okay? So just keep chipping away at it little by little. Here, you're doing some more mental math, meaning these are things you should be able to do without a calculator and just in your head. You're practicing trying to force your brain to make these connections and to problem solve in a way that's going to help you do lots of types of problem solving in the future, okay? So here, the strategy that is suggested is that you take the second number and increase it until you get it ending in 0, and you also increase the first number by the same quantity. So for example, 63 minus 28, if you want to make 28 and increase it up to 30, then you would increase the 63 up the same amount as well. So to get 28 up to 30, you would add 2, so 63 has got to go up to 65. So I just added 2 to both of those numbers, and 65 minus 30 is easier to do in your head because when you subtract by the second number that ends in 0, 65 minus 30 is just 35. Same thing here, 45 minus 17. If I want the 17 to go up to 20, I did that by adding 3, so 45 has to go up to 48. I also add 3 to 48, and then I subtract these. So 48 minus 20 is just going to be 28, because it's easy to see that 28 plus 20 gives you the 48. Okay? I had mentioned before another way to do it. Let's take this one, 80 minus 46. 80 minus 46 is you're trying to figure out the difference between 80 and 46. How many numbers, or what's the value that's between 80 and 46? That's what you're doing when you do subtraction. You're trying to find the difference between those. So if you went from 80 down to 46, how much did you drop? Or if you went from 46 back up to 80, how much would you have to increase? That's really what you're trying to find, the difference between these two numbers. So you could, from 46 up to the next multiple of 10, I would have to add 4 to go from 46 to 50. And then from 50 to 80, I hope you see that's easy. You just add 30. So I added 4, and I add 30, so I have to add a total of 34, which means the difference between 80 and 46 is 34 if you were to subtract them. It's another way to approach it as well. Okay? Adding here. So if you add these here, you can add them thinking different ways. Again, one way that I think about it is I actually add the numbers that are in the place, then in the tens place first, 4 and 3, and I know that that's really 40 and 30, so that's going to give me 70, and then the 8 and the 4 are going to give me 12. Together, that's going to give me 82. That's one way I think of it, okay? Here, 24 times 100. Here, you're really multiplying by a power of 10, so that's going to be 2400. It's really easy to multiply by powers of 10 because you just basically are adding that number of zeros on. All right? And then here, when you're subtracting, this is money values. You can think of it the way I did over here as well. You can do it, lining up the decimal points and doing subtraction, borrowing, all that. You can also figure out how much do you have to add to 585 to get back up to $10. So to go from 585 up to $6, I would have to add 15 cents, and then to go from $6 to 10, I would have to add $4. So I added 15 cents, and then I added another $4. So that's a total of $4.15. Okay, the 15 cents added to the 585s brings it up to 6, and then you just needed another $4 to bring it up to 10. All right, so that's another way to think of subtraction. when we count by fives, starting at 5, the numbers end in 0 or 5, meaning 5, 10, 15, 20, 25, etc. All the numbers end in either a 5 or a 0, 5, 0, 5, 0. When we count by fives starting at 1, 1, and then if I add 5, I get 6. And if I add 5 to that, I get 11. If I add 5 to that, I get 16. If I add 5 to that, I get 21. You can see the numbers end in 1 or 6. Okay? If you count by 5 starting at 2, if I add 5, I get 7. If I add 5, I get 12. If I add 5, I get 27. If I add 5, I get 32. If I add 5, I get 37. You can see the numbers end in 2, 7, 2, 7, 2, 7. Okay? So you can see here, then that's going to be the case. For 3, they're going to end in 3 or end in 8, which is 3 plus 5. So 3, 8, and then if you add 5 again, you're going to get 13, and then 28, 33, etc. 3, 8, 3, 8, 3, 8. If you start with 4, 4 plus 5 is 9. All the numbers will end in 4 and 9. Okay? So it's kind of a neat little pattern that's useful to figure out, because you're going to see patterns all the time in mathematics. Okay? All right, let's talk a little bit about the new concept here. We're looking at dividing again. So remember, we are going to follow some different steps in order to do long division. So we'll just repeat those steps over and over and over in order to do long division correctly. All right? Notice here the steps that you go through, you do that once, and then if you need to keep doing it, you circle back and you continue those steps all over again. So for example, if we want to do long division here with 3 into 618, which is another way to write this is 618 over 3, you first take it a little by little. You look at the 3. How many times does 3 go into 600? That's really what you're talking about there. 3 into that first 6. That 6 really is 600. But 3 into 6 here is going to give me 2. 2 times 3 is 6. And I place it right over the 6 because really what that means is 200. 2 times 3 is 6. I multiply. Then I subtract. I get 0. I bring down my next number, which is a 1. So does 3 go into 1? No, it doesn't. So I put a 0. Then I bring down the next number. Well, I can take 0 times 3 if you want to, and then subtracting and just get 1. But then you bring down the next number, and now you have 18. Does 3 go into 18? Yes, 6 times, and that would be evenly, meaning 6 times 3 is 18. You subtract, you get 0. And so you don't have to bring down anything else, because the rest of them are just zeros anyways. If you want to, you can put 0.0, as many zeros as you want to. But your answer here now is 206. Another way to think of it is 3 times what equals 618. And we just discovered that that unknown number is 218. 3 times 218 equals 206, my fault. 206 equals 618. Okay? All right. This is just showing the whole process for you. You can look at that if you need to. If we want to do this one, let's do another example. 4 goes into 1,483. So we go little by little. Does 4 go into 1? Not really. Okay? I mean, it does, but it doesn't give you a whole number. So does 4 go into 14 then? You expand it and take 2 digits. 4 goes into 14. Let's see. What times 4 gives me close to 14? So 4 times 4 is 16. That's too big. How about 4 times 3? 4 times 3 is 12. So I'm going to go 3, and I'm going to put it right above the number that I am dividing into. 3 times 4 is 12. And then you subtract. 14 minus 12 is 2. Bring down the next number. Now you go 4 into 28, which is exactly 7. 7 times 4 is 28. Subtract, you get 0. You don't really need to write the 0, but we're going to put it there. Bring down the next number, 3. Does 4 go into 3? Not evenly, so I'm going to put a 0. And then I'm going to subtract, and this is my remainder. What that means is that's how much I have left over. 370 with a remainder of 3. Another way to write that, by the way, is your answer is 370, and you've got 3 over 4 as the remaining part of your answer. So 370 and 3/4. That's going to come up later on, so I'm just letting you know that you might see that later on. Okay? I'll let you look at example 3. You can pause it right now and make sure you understand example 3. So let's go through the practice here, okay? We're going to do the different steps in order to divide. So 4 goes into 8/15. Does 4 go into 8? Yes, it goes in 2 times. 2 times 4 is 8. And I subtract, I get 0. Bring down my 1. Does 4 go into 1? No. So I could take 0 times 4 and get 0, and then subtract, but I just get 1. So bring down the next number is 5. Does 4 go into 15? It does, not evenly. 4 goes into 15. 4 times 4 is 16. That's too big, so 4 times 3 is 12. And if I get 12 there and subtract, I'm going to have a remainder of 3. So once I get to the end of my number, I'm just going to put R3, showing that's how much I have left over. Okay? I'm going to do another one for you, and then you can work on the remaining ones on your own. Again, let's take it number by number. Does 5 go into 4? No, 4 is smaller than 5, so you can't have multiple 5s going into 4. So I'm going to go one more number and combine the 2 here. Does 5 go into 40? So what times 5 gets you close or exactly 41? Well, the closest number is 8. Good. 8 times 5 is 40. Subtract, I get 1. Bring down the 5. 15. Does 5 go into 15? Yes, evenly, 3. So 15 minus 15 is 0. Bring down the 2. Does 5 go into 2? No, I put a 0, and that's how much I have left over, remainder of 2. Okay? Now you do D, and you do E, F, and G, and then let me know if you have any questions on those. Okay, let's go through the mixed practice now. What you need to do is you need to pause this video now, if you are watching this before doing this mixed practice, and you need to try all 30 of these problems all on your own. Struggle with them. Keep going. Don't give up. Fight for the answers. And then if you need to, look back at a lesson. It'll say right here what lesson this refers to. So look back in your book at that lesson, just if you need a little refresher. And then check your answers. If your answers are correct, great. If not, mark that problem, and then maybe you want to continue this video to see if what I share with you helps you understand it. Okay? All right, so pause, finish the mixed practice, and then come back. Okay, let's go through the mixed practice together. I'm just going to make a few comments and then see if you have any other further questions that we can talk about later. If the chance of rain is 30%, so rain means there's a 30% likelihood that it's going to rain. That means the other option is it's not going to rain, and that's a 70% likelihood. Notice these two percentages, there's only two options, rain or no rain. Those two percentages have to always add up to 100. All of the percentages of some possible outcome always have to add up to 100. That's what percent means, per 100. Then which is more likely? That it will rain or that it will not rain? Well, the not rain is a higher percentage, so it's more likely that it's not going to rain. Monty ran the race 12 seconds faster than Ivan. Monty ran the race in 58 seconds. Ivan ran the race in how many? So let's look back at this word, this sentence right here. Monty ran the race 12 seconds faster than Ivan. So the first thing you might want to think about is whose time is going to be bigger, whose time is going to be smaller. If Monty runs faster, he's going to get done 12 seconds earlier than Ivan. That means his time is going to be less. So Monty's time, I'm going to put a capital M for Monty's time, and if I take Monty's time and I add 12 onto it, that will give me Ivan's time. Ivan's time, I have to add 12 more seconds to Monty's in order to get Ivan's. Monty's is the smaller value. If I add 12 to it, that will give me Ivan's. So now it says Monty time was 58, so that means 58. But if I want to get Ivan's, I have to add 12 to it, and now that would give me Ivan's time. So 58 plus 12 is 70. 70 seconds is Ivan's time. And here we have, you have a rectangle, and that's divided into 5 equal parts. That means if you take this, 100% is representing the entire rectangle. If we divide it into 5 equal parts, each part now is going to be a fifth of that rectangle. That means you're dividing by 5. 100 divided by 5. 5 goes into 1. No. 5 goes into 10. Yes. 2 times. And then 2 times 5 is 10 exactly. So that's 0. Bring down the next number, which is a 0. 5 goes into 0. 0 times. So 5 goes into 100 20 times. So each part here is going to be 20%. 1/5. 1/5 is the same as 20%. That's something you probably should just commit to memory and just know, okay? All right, how many 6-inch long sticks can be cut from 72-inch long stick of sugar cane? So if you've got a 72-inch long piece of sugar cane and you want 6 inches, you're going to divide it into 6 inches. So each of these is going to be 6 inches. 6, another 6, another 6, another 6, another 6. How many of these are you going to get out of 72? Well, basically you're taking the 72 inches and you're dividing it into pieces that are each 6 inches. So how many 6s are you going to get out of 72? 72 divided by 6, and you need to figure that out. Number 5, 1/5 of the leaves have fallen. What fraction of leaves have not fallen? Again, fractions always add up to 1. So if 1/5 have fallen, that means that 4/5. 1 out of 5 have fallen. That means 4 out of 5 have not fallen. Okay? Imagine if you only had 5 things, and I said, out of those 5 things, 1/5 has done something. Okay? 1 out of a total of 5, well, that means you have 4 left. 4 out of 5 remain. Okay? Which of these arrows could be pointing to 5263? Well, right in the middle would be 5,500. So A here is going to be between 5,000 and 5,500, which is that number right there. So it's probably A. What fraction of the months of the year have 31 days? Oh my. Months of the year have 31 days. So what you want to do is you want to figure out what months have 31 days. There are 12 months. How many of those months, January through December, have 31 days in the month? And that would be your top number. Okay? So this is the number of months with 31 days divided by a total of 12 months. And that's going to give you the fraction. Okay, prefix kilo means what number? A kilo, like a kilogram means 1,000 grams. If I say a kilogram, that means 1,000 grams. So the word kilo, or the prefix kilo, must mean 1,000. Estimate the sum of these 3 numbers by rounding each to the nearest hundred. So 393, let's round that up to 400. 589, round that up to 600. And 241, you're going to round that down to 200, because 250 and above gets rounded up to 300, but 249 and below gets rounded down to 200. So just add these, 4, 6, and 2. 4, 6, and 2 is going to give me 1,200. These are hundreds here. Okay. Triangle is equilateral. How do you know? Well, they're telling you, but it means that it would have all the 3 sides are equal in length. How many millimeters is the perimeter of the triangle? So you'll notice that one side here is a length of 2 centimeters. Well, 2 centimeters equals, because 1 centimeter is 10 millimeters, 2 is going to be 20 millimeters, and therefore all three of these added up, you're going to have 20 millimeters, another 20, and another 20. 20 plus 20 plus 20 is a total of 60. So your perimeter is going to be 60 millimeters total. Perimeter is the distance around the triangle. Okay, 3 liters equals how many milliliters? So if you've got 3 liters, they want to know how many milliliters is that? Well, 1 liter is 1,000 milliliters. Okay? So that means if you've got 3 liters is going to be 3,000 milliliters. Wilma could run 5 miles in 1 hour. So if we write that as a rate, the rate of her running is going to be 5 miles per hour, 1 hour. At that rate, how long would it take her to run 40 miles? So that means 5 miles takes her an hour, 10 miles would take her 2 hours. I just doubled that everything. Then if we did 15 miles, if I triple the length, then it's going to take her 3 hours. And you can see where this is going. So if I take 5 times 2, I get 10. I take 1 times 2. If I take 5 times 3, I get 15. I got to take 1 times 3. So I need to figure out 5 times what gives me 40. Or another way to think of it is 40 divided by 5, that gives me 8. So she's going to do 5 miles, another 5 miles, another 5 miles, another. She's going to do that 8 times for a total of 40. So if she does that, if she runs 5 miles 8 times, that means each time she does 5 miles, that's an hour. And she did it 8 times. So that's a total of 8 hours. Okay? That's what we got right there. All right. Remember here, this is asking a question. 2 times what? This is your question mark. Equals 150. So you might be able to think of that and just decide it in your head and figure it out in your head. But another way to do it is to divide both sides by that 2. Because basically you're saying 2 times something equals 150, so let's divide it into that many equal parts, into 2 equal parts. So 150 divided by 2, when you do that, you're going to get 75. I'm going to let you do this computation. Just make sure you do everything in parentheses first. So you want to add first and then subtract second. Do all of these here. Don't neglect any of them. Do them all. Every single addition, subtraction, multiplication, division problem, make sure you're doing all of them. Okay? I'll make one comment over here on number 18. It says 60.5 or $60.50 minus something gives you 43.20. Well, another way to think of that is, if you want to find out what n is, that would be $60.50 minus 43.20. Again, in my mind, what I do is I think, what do I need to go back up to 60 there? Or you can do regular traditional subtraction problem. Do your subtraction, division, multiplication, practice all of this, get really, really good at it. You're going to use addition, subtraction, multiplication, division for the rest of your life. So you want to be very, very confident and master this so that it is automatic. Okay? Let's jump down to number 28. When you do this one here, we want to find out what W is. So let's do everything on this side that has just numbers. Do everything in parentheses first. So we have 9 times W equals 9 squared plus, and then parentheses we have 9 times 2. Now, the way I want you to attack this is, I want you to just do one step at a time, write everything down in the next step, and then do the second step and the third step. But you have to be methodical, neat, organized. Be careful. That's how you get the correct answer. You don't want to be sloppy. You don't want to be lazy about this, okay? So 9 times W on the left side, and in parentheses, that tells me do parentheses first. In a group, that's why you put it in a group, is it tells you do that first. okay? So I'm going to write everything else exactly as it is, but I'm going to do whatever's in the parentheses. It says 9 times 2. 9 times 2 is 18. Now I don't need to write the parentheses anymore. Now, next, I'm going to do exponents. 9 squared, that means 9 times 9. That's 81. Notice I only did one thing at a time. Everything else is untouched. Now I can add. 81 plus 18 is going to give me 99. Okay? Notice I did everything on this side because over on this side I have something that I don't know. So I'm not going to bother with that quite yet. I did everything on the right side because I have numbers that I can evaluate, and all of that equals 99. Now it comes down to a question. 9 times what? That W right there is like representing some number. I don't know it, but I can figure it out. It gives me 99. 9 times what gives you 99? If you don't know, you could divide both sides by that 9, because 9 divided by 9 is going to give you 1W. And that's what you want to know. So now on this side, whatever you did on the left side, you got to do the right side. 99 divided by 9 gives me 11. Okay. Here, divide mentally. 5 goes into 3,000. Well, 5 doesn't go into 3. 3 is too small. So I go the next numbers. I take two of the first numbers. Does 5 go into 30? Yes, it goes in there 6 times. And then it goes in perfectly. So I'm not going to have any remainder, and everything else is just zeros. So I just have 600 as my final answer. Make sure you put the number right above the one that you're dividing into. So my answer is 600, not 6, 600. Number 30, draw a triangle that is congruent to this isosceles triangle, then draw its line of symmetry. So congruent means it is exactly the same length, same angle, everything is the same about it. So we could do our best here to draw a triangle that is congruent. It may not be perfect, but we'll try. And then draw the line of symmetry. The line of symmetry is going to be straight through the middle so that you have 2 equal halves. Straight through the middle, so it's like a mirror, and you have 2 perfectly equal halves on that triangle. Okay? All right. I'm going to stop right there. And then next time we'll look at this investigation number 8 and move into the next lesson as well. Okay? Keep working hard. Let me know if you got questions.